Good morning, everyone, and welcome to the second session in F5 EMEA's My Forum webinar series. As an alternative to our traditional forum events, we've created My Forum, which is a new virtual learning experience and content hub packed with F5's latest updates and insights. So what we do is we leverage the expertise of our top architects, engineers, developers, and by doing so, we'll help you navigate today's most complex application delivery and security challenges on the one side. And for service providers specifically, we'll deliver insights into how F5 technology can help them solve some of their current business challenges. My forum brings all this content to you from the comfort and safety of your home office. And just like you, myself, and Raffaele here on the call, we are based in our home offices as well. I'm Bart Salat. I'm head of F5 Solution Architects in the EMEA region, and I will be your facilitator for today's webinar, which is a session in our service provider track, and it's focused on video traffic management to help service providers reduce congestion levels on their networks. Now, before we get started, a couple of housekeeping items to note. First of all, you can adjust the size of your presentation box on your console by expanding the corners of the box. The video box, however, cannot be resized, but it can be maximized. And this will be very useful for you once we move over from the presentation to the demo, because the demo is actually going to be shown in the video screen, not the presentation box. If at any time throughout this presentation you experience connection issues, please try refreshing the console by pressing the F5 button, or if you're on a PC, Command plus on your PC, or Command plus R if you're a Mac user. If the problem persists, just close the event window and relaunch the event. If you have any questions throughout the presentation, please submit them in the Q&A box, and we will have a live Q&A session at the end of this presentation. So I will go through your questions, and together with Raffaele, we'll try to answer them as good as we can. We will be sending out a link to the recording of the presentation afterwards. So today we have with us my dear colleague, Raffaele D'Albenzio, manager of the pre-sales team that is responsible for our top service provider customers in EMEA. And he will talk about how to reduce congestion on service provider networks with intelligent video traffic management. Raffaele, over to you.
Thank you very much, Bart. Good morning, everybody. As Bart said, we're going to talk on how to manage video traffic in the service provider networks, trying to reduce the congestion in case of a specific event. So the agenda will go through 4 main topics. The first one will be how, let's say, the video is impacting today the internet traffic, and we will, as you will see, we'll take an example that is touching all of us in this period that let's say we have been impacted in the last few months. Then we will try to go at very high level on the way today the video streaming technology works on the internet, especially the one delivered by the main content providers, but in reality everybody is following a very similar approach. And then we will see how, considering how the video streaming technology works today, how F5 can help on managing the video traffic over the internet. And then at the end we'll see a quick demo, which will be shown as a quick video, just to give you an idea on how the technology works and what is, let's say, the benefit that you can get when you implement this kind of technology in your infrastructure. So let's start from the first topic, which is, as I said, the impact of the video traffic on the internet. And as I was mentioning in the beginning, we are taking as an example what happened in the last few months. We all know that COVID-19 had an impact on the service provider network. We lived, let's say, we perceived in a different way. Everything started with the lockdown. I took a snapshot of a newspaper talking about Italy. I'm actually based in Italy, so I was one of the first that was in some way impacted and started, let's say, working from home because of the lockdown, and also the whole family was at home, including the kids that were doing remote learning, trying to have their teacher teaching them from using the typical video conferencing tool that we all use. That obviously had an impact on the internet traffic, and we saw this impact, I would say, in two different ways. The first one was announcement from service providers. So I took one, for example, that is talking about Vodafone in this case, which was reporting 50% of traffic increase because of people working from home or people staying at home. In general, Vodafone is a good example because it's an operator that is covering the whole Europe, I would say, and even more. It's a real global operator from this perspective. So it can give an idea that this was having a global impact on the internet traffic. But if we want to measure it, let's say, with public numbers, we also see increases on public graphs from Internet Exchange Point. So the Internet Exchange Point, and again, I took the one from Italy, the Milan Internet Exchange, but if you take the London Internet Exchange or the Amsterdam Internet Exchange, which are the biggest one in our region, they had more or less the same impact. So you see an increase of traffic which is comparable with the announcement that Vodafone made. So there has been this traffic increase, which, by the way, was not only on the fixed side, because some people were claiming that this was mainly on the fixed access, but it was also on the mobile, on the wireless network, because there are still people that are using mobile where they are sitting at home. Now, somebody could ask how this is related to the video and why this should be related to the video. The reason because it's related to the video is because the video has two, let's say, main elements regarding to the internet traffic. The first element of the video traffic of the internet is the fact that video is the majority of the internet traffic today. So this is a snapshot of a public report published by Ericsson. This one is from end of 2019, and it shows that today 63% of the internet traffic is mainly video. So we are way above half of the traffic that is video today. And more interesting thing is that this is going to grow more and more, and it's going to become 75, 76%. So 3/4 of the traffic will be video in the next 5 years on the internet. So this is the first topic, the first element that makes video different from the other traffic. The other element is that the same content of a specific video can be delivered in a different way and can consume a different amount of bandwidth depending on the way it is delivered. And this is mostly related to the quality of the video itself than, for example, time. So I give you an example. If you do a file download, if you want to use less bandwidth, you will get your content later, okay? In the video, theoretically, you can get your content in real time or with the same level of streaming in terms of time. You just have to accept to reduce the quality of the delivery of the content itself, of the video itself, in order to make sure that it's possible to watch a specific video. So these two elements that are, let's say, combined together, as I said, make the difference of the video respect to the other traffic. And this was also realized by, for example, the European Union. So what the EU did to save bandwidth, in particular during the COVID-19, was to ask to the main content provider, and you can find a public tweet where there was a conversation between Terry Breton and the CEO of Netflix, where there was this hashtag called switch to standard, where Netflix was asked to decrease the quality of their video from high definition to standard definition wherever possible. Wherever possible means probably depending on the client, depending on different parameters. But this was in some way asked by EU to the content providers in order to make sure that internet could cope with this, let's say, unexpected increase of the traffic on their infrastructure. And this was all obviously not only for Netflix, but you see other news that happened just after Netflix, where other content providers did the same. So YouTube started reducing the quality of their video in Europe. Amazon Prime Video did the same. Apple TV Plus did the same. So the main content providers, which are probably the main contributors of that 63% of traffic that we were seeing before in the previous slide, contributed to reduce a lot the impact of the increase of the traffic, of the internet traffic during the COVID-19 period. We all know that, I think it's a news of last week, they are coming back to the normal delivery now, but this was a decision that was done because, let's say, of an emergency and an unexpected situation. Now the point is, should the service provider wait for the content provider to decide to reduce their bandwidth in order to make sure that the backbone is not impacted or the access is not impacted on their network infrastructure? In order to understand if they can do something by themselves, we need to cover a little bit the way the video streaming technology works. So what I'm trying to explain in the next slide is, as I said, at a very high level, how the video is delivered today. We know for sure that the video is available at a different resolution because, as we said, the content provider decided to reduce the resolution of the video by themselves. So they were able to do it in almost real time, and they didn't have to re-encode all the videos because it was already available. But in reality, this kind of, let's say, quality delivery can be decided based also on other parameters, and it can be in some way adaptive. And this is the concept that is available on the internet of adaptive bitrate. So this is the way the video is delivered today. The video today is delivered using two transport protocols. HTTPS over TCP is I would say the most used one, or it was the most used one until some months ago. As you see, it's HTTPS, so it's encrypted. Or recently, Google came up with a new protocol called QUIC. QUIC is, as I said, a protocol invented by Google, but it's becoming a standard. So there is a working group in IETF which is defining the standard version of QUIC. And the characteristic of QUIC is that it's running on top of over UDP. It's not running on top of TCP, but it's running on top of UDP. However, the behavior of the adaptive bitrate is more or less the same between the two protocols, and it works in this way. So you have your live stream or your origin server, if you're talking about obviously an event like a football match or a concert, or the origin server, which is just storing the video. The video, which is one of these two options, is sent to, let's say, a software which is implementing different functions. The first one is splitting the video in chunks. So the video is divided in chunks, typically of 10 seconds, depending on the technology, but we're talking about 10-second chunks or 20-second chunks, order of tens of seconds. Then every chunk is sent to an encoder, which is encoding all the chunks at a specific resolution. Typically, the resolution go from 240p up to, I would say, Ultra HD, so 4K. In this slide, we are just showing three options to make the slide easier to read. And then the different, let's say, chunks at the different resolution are sent to the media server. Once the media server is having the content, you will have this content delivered to the client, and the client, okay, will ask for a specific content to a specific resolution. So there will be a client maybe with a big screen which is requesting the content at 4K. There will be a client with an intermediate screen, for example, that is asking for the content at full HD, so 1080p, or a client which is delivering the content, asking the content at 720p. During, let's say, the download of the chunks of the video, typically the client can change this behavior, even if there is one important element. The client is typically trying to use all the available bandwidth. So the client is an application, and most of the time is considering only the option of the application that is used in this case. So what is happening is that the client is trying to use the majority of the bandwidth. But in case, for example, a client measures a lower bandwidth because, I don't know, the quality of the radio is lower in case of a mobile network, the client is detecting the lower bandwidth, and then it's asking to have a lower resolution video to the server, and the server is sending on the next chunks a video, which is, for example, in this specific slide, going to 720p. So because the video is adaptive, we can do on, let's say, the network side something in order to try to control the ways the video is delivered to the client, applying what can be called policies, bandwidth-based policies on these specific video flows. The solution that F5 provides, and then now we go on the way, we are preserving the service provider resources. The solution that F5 provides, let's say, it's part of a broader option that F5 can deliver, which is the following. So you have the typical architecture that you have in the service provider network is based on, as we said, origin server, internet traffic. Then you have the service provider backbone. And then the video can be delivered in two ways. You typically have a managed video solution, which is the video that service providers are offering together with the connectivity. So it's their own IPTV solution that is used to deliver this content. And if we call it managed video, F5 in this area can offer two solutions. The first one is a caching solution, a video caching solution based on the NGINX Plus. As most of you know, in this webinar, probably we acquired the NGINX 1 year ago, NGINX technology, which is a DevOps-centric application delivery solution. And the good thing of NGINX is the fact that NGINX has a very efficient cache engine that can be used as a component of a content delivery network, a very efficient content delivery network. And for example, this was decided by several content providers to use it. I'll give you an example. Netflix uses in their caches today NGINX technology. And there are also other presentations from service providers that are also content providers during the NGINX conference that were showing how NGINX was used by them in their content delivery solution. So an example is, for example, Charter that presented during the NGINX conference a couple of years ago. The second element is F5 as an ADC solution in the data center, in the IPTV data center, to provide ADC and security solution. Examples are SSL offload of the front end or the video streaming itself, protecting the user authentication, which is very important today. The platform, the IPTV platform that requires authentication are attacked to staff credentials. So there are solutions that F5 can provide in this area to protect user authentication and also to improve the user authentication experience in this area. What we are going to touch during this webinar, it's more on the unmanaged side. It's an unmanaged OTT video, as you saw in the beginning of my presentation. We are going to talk about the traffic that is an over-the-top, which is managed and has to be managed from a network side perspective, where with F5 technology sitting on what is called GI LAN on the 4G access network, or N6 LAN, where we're going to talk about 5G net. So how to manage video coming from the content provider to make sure that we can preserve, in this specific case, backbone, but mainly the access, the network access, which is most of the time, let's say, a precious resource, especially when we are talking about mobile. In this context, F5 can do several things. We can provide different solutions on the GI LAN. As you can see, F5 can provide security with carrier grade NAT and GI firewall, a DNS advanced solution from cache and resolver up to DNS security, which means offering security services to subscribers using parental control, for example, or securing a DNS cache and resolver that is sitting on the edge. And last but not least, the video and the IP traffic management, which is the topic that we're going to touch during, we are touching during this presentation. So how the F5 technology works? It works based on two main components. The first one is the detection of the video traffic. So F5 has a specific module which is able to detect adaptive bitrate flows. So the important thing here is not just detecting that a specific flow is a video, but detecting that a specific flow is an adaptive bitrate video. Because if you start applying policy to a flow which is not adaptive bitrate, the quality of experience will be lower because we will start stalling this video. So we have to detect that the video specifically is ABR in order to make sure that if we apply the right policies, we are not going to stall the video, but we are just going to manage the video in a way that is saving service provider resources, but the video is still delivered to the subscribers. Then once the flow has been detected, and this is important, the flow is detected both if it's HTTPS over TCP, so both for encrypted video over TCP, and also if it's quick over UDP. So F5 is able to detect ABR video flows, both in case of TCP and UDP. In both cases, F5 can provide the capability to control the bandwidth of these flows in order to make sure that the flow can be paced in a way that two possible use cases are going to be and can be implemented. And we will touch the use cases a little bit more in details in the next slides. But the concept is simple. On TCP side, we can start applying rate limiting, working as a TCP proxy. F5 technology is a full TCP proxy. So in this case, we work on both sides, network sides and subscriber side, in order to make sure that the TCP flow is paced in the right way. And in the case of UDP, we start doing pacing of the UDP flow in order to make sure that, again, the bandwidth can be controlled and we avoid spikes and we avoid, in case it's needed, to go to higher resolution. How does it work? The next slide is showing a little bit of an animation on the way it works. So you have this architecture, okay? You have your video content that is coming from the origin server. It's typically sent in bursts, so it doesn't always happen. It depends on the content provider, but in several cases you can see these bursts. And by the way, even the content providers themselves sometimes can change over time the way they deliver the video. They start using bursts, but then they can use pacing, or in some areas they can just send based on bursts, but then they can pace the video itself in some specific situation. The point is that even if the F5 technology receives the bursts, once the ABR flow is detected, so once the solution is able to detect the flow, a rate pacing solution, which, as I said, works in a little bit different way between TCP and UDP, because with TCP we can behave as a full proxy. With QUIC, because it's UDP and QUIC is encrypted, even from a flow control perspective, we cannot be a full proxy in the sense that we cannot manage the flow control because the flow control is encrypted. Itself. But once we apply the pacing, then the video is delivered in a much, let's say, more controlled way in order to make sure that the subscriber can get the best quality of experience, considering the quality of the radio access network if we are talking about mobile. Now, one question that comes is, but can I do that? Can I just control the video? Does it not violate the net neutrality, for example, in case of EMEA? The rules of net neutrality are, I would say, pretty clear in the sense that net neutrality consider the option from a service provider perspective to treat specific traffic categories when there are reasonable situation, where you have to do that because, for example, mitigate network congestion. Here there is the link to the document from BEREC. BEREC is the body of European regulators for electronic communications. So it's the EU entity that, let's say, issued the documents and the directives related to the net neutrality that are then implemented by the different countries. I see in this call we have people also not from Europe, but obviously this is strictly related to Europe. But the point is, even in the case of net neutrality, there are situations, and you see the list here, situations of emergency, and for example, COVID-19 was the typical emergency that was unpredicted, beyond the control of service provider. Again, there could be situations of emergency where the network is congested. And by the way, it could be congested even in specific areas, because there are some specific events in some specific area, and they don't have to be necessarily of short duration. That's another element of importance that the EU takes in consideration. So service provider can do that, can control the traffic as soon as they treat the category equally. So if you have ABR video, and you take the ABR video as it is, you don't differentiate between one content provider versus the other. So you cover, I would say, the majority of the video traffic that is going to be delivered through your network. In reality, at least from the way the document is written today, you are not really violating the net neutrality rules. Now, coming back on the use case, as I was mentioning in the beginning, there are two possible use cases that could be implemented. The first one is called just-in-time emulation. Why it's called emulation and just-in-time? Just-in-time is the typical terminology that was used by the transcoding-based video optimization solution. What is it? It's just a way of reducing the pre-buffering that clients from content providers are doing when a video is delivered. So you typically see, for example, in the case of YouTube, you typically see around 60 seconds pre-buffering. Actually, even this number can change depending on the client, depending on the video, depending on the application. But in general, you see in average 60 seconds of pre-buffering. Because as I said, YouTube is using, and every client, is not only YouTube, every video client is trying to use all the possible bandwidth available at a specific time. The point is that if somebody stops a video earlier, the service provider downloaded 60 seconds of video, but in reality it was for nothing because the customer, the subscriber, is not reproducing those 60 seconds of video. So if you reduce the amount of buffering without impacting the quality of experience, for example, in this case, we were reducing from 55 seconds to 15 seconds, as you see from the slide, you can consume less bandwidth. So just to give you an example, if your customer was playing 30 seconds of this video, you were downloading 1 minute and 30 seconds on the first case, and you were downloading 45 minutes in the second case. You were saving more or less 50% of your bandwidth if you are applying a rule that is implementing just-in-time emulation. So just-in-time emulation is one option. The other option is to control the resolution. This is in some way what has been done during the COVID-19 by the content provider themselves. And because of the adaptive bitrate, when you apply the pacing to a bandwidth, which is, for example, an estimated value related to a specific resolution, I was making the example of YouTube in the beginning of my slides, but obviously there are typical value for the majority of the content providers that are delivering content on the internet today. So applying rate pacing at a specific bandwidth, a specific speed, can force the client to reduce the resolution and make sure that you are saving bandwidth in your network. And by the way, it doesn't have to be done for all the clients. It can be done in a dynamic way. And I will give you a little bit of more details in one of the next slides. So what we did with several customers, we delivered the solution in production. For one customer in particular, we were making one test to show the saving. So this customer was using one video from YouTube, which is this one. It's called Endless Space. It's a 4K video. And it's available, as you see, at a different resolution from a very small standard resolution, 144p, up to 4K. And the duration of the video is pretty small. It's 1 minute. What we did was comparing and analyzing the saving, in particular in the second use case, so when the resolution is lower. So what we did was starting with an unoptimized, uncontrolled traffic use case test. So we captured the flow, and we got the first graph. What we saw on this graph was that the peak of the bandwidth was 110 megabit per second. This line actually was a fixed line which was able to reach over 320 megabit per second. The average bandwidth was 40 megabit per second, and the video was delivered obviously at the maximum resolution, so 4K delivery. The point is that the graph, as you see, is bursty. So the video in this specific case was bursty, was sent in a burst of traffic, and the size of the downloaded file was at around 174 megabyte. Then we run the same test, start pacing at 10 megabit per second. As you see, the graph is much more, let's say, much less bursty. The peak was 60 megabit per second, and the average was 10 megabit per second as expected, because we were pacing at 10 megabit per second. The graph was much smoother. The downloaded size, as you can see, was 55. So we moved from 164 to 55 megabyte of data downloaded. And the resolution was between full HD, so between 1080p and 1440p. So the traffic the video was changing resolution over time. And this is coming from the chunks, the concept of chunks I was mentioning in the previous slides. Then we did the same at 7 megabits per second. More or less the graph was the same. The peak was a little bit higher, and the pacing was in average 7 megabits per second as expected. The graph was still smooth, and it was a little bit smaller, just a little bit smaller, 50 megabyte instead of 55 megabyte. Resolution was full HD the whole time. And the amount of traffic that we saved was 5 megabytes respect to the previous one. Now, if I compare the last one with the first one, which is what we need to do if we want to measure the optimization, but even the second one, which is very similar, so pacing at 10 megabits per second is okay as well, we reducing the amount of data downloaded from 174 megabyte to 50 megabyte, we are saving 70% of the traffic. Now, the point is that a mobile operator could ask himself that they are not really saving, because in reality the bandwidth is charged to the customer, because at the end of the day the customers have typically a bucket of 5 gig, 10 gig, 20 gig, whatever it is. In reality, if we see what happens today, the world is moving to unlimited data plans. This is one aspect that is important. And the other important aspect is the fact that customers that are using their bucket in a more efficient way tend to reduce the churn in a service provider network. So even if you are charging your customer with a specific bucket of data, so if they are consuming more, they are paying you more, they will be probably willing to change service provider because they are finishing the amount of data sooner than other than later. And not all the customers are able to change the resolution by themselves to change, to save the data. For example, we had one customer which wanted to apply this kind of policy only for customers that were reaching like 70% of their bucket before the end of the month, because they wanted to preserve the fact that these customers were impacted from their quality of experience. And that comes to the next slide, which is what we call this, just as an introduction. Obviously, we could talk hours on all the possible options that our technology has to implement this policy. But F5 technology can implement this policy in a dynamic way. So the approach is that one size fits all doesn't work in this case. You can have different customers that need to apply these policies in different conditions. As I said, emergency reasons in the beginning. You want to save your bandwidth because of unlimited data in some situation. You want to save service customer experience without having them finishing their limit in advance. Several reasons and several services could require different kind of policies applied to your subscribers. So it could be time-based, for example. It could be location-based. As I said, you can have congestion in a specific area. It could be subscriber-based. If you have a specific subscriber with a specific way of charging, and it can be a combination of them. So you can have an hybrid solution, which is applying some of them for some subscribers, some others for some other subscribers. The other point is, how do I measure how much, let's say, video I am delivering, and how do I measure how much I am saving in my infrastructure? What F5 can do today is it can export statistics of the flows to external analytics tool. So, for example, you can build your own report using commercial tools, or you can use open source tools like this example in this slide. Which is showing an example of a report using Elasticsearch, Logstash, and Kibana. So obviously the dashboard is Kibana. Logstash was used to collect the log, and Elasticsearch to build the indexes that were used to build the log. But the way we produce log is pretty flexible. We can even adapt our format of logs to the analytics solution. So the integration phase is typically very simple and very quick. We typically work, for example, with partners as well that are maybe skilled on specific analytics solution, and we can provide joint solutions together with them. Let's go quickly in a demo. So I'm going to share the screen now, showing the video. So you should see in the video now a logo, an F5 logo. I'm assuming you see it. But I don't know if you can hear me. Can you just confirm that you see my video?
I cannot see it, Raffaele, but...
Okay, let me just try again. Okay, you see it now? I just want to make sure it's...
Yeah, I think people will see it. Yep.
Okay,
yep.
Perfect. Okay, so the video shows a demo of a user that is connected to the internet, and it's in the middle between internet and I mean, there is a big IP in the middle between the user called John and the internet itself. So you see in this video a web UI of F5, so the web interface of F5, and on the right side just John's iPad. So you see that there is a policy called video log. So the policy is just logging the video, is not applying any bandwidth control. Okay, so we're just analyzing what happens. We play the video. The video is from an agility session. When we see the statistics of the video, it's having a spike at in this case 18 megabits per second. The video is up to full HD, by the way. It's not a 4K video. So it's going up, and then you will see in this case it's a little bit different. There is no burst because the content provider itself is spacing the video, or maybe there is already something in the middle in the network that is spacing the video itself. But the video is spaced at around 5 megabits per second. So when we play the video, we see the video at full HD. It's a 1080p, and the buffering it's around 60 seconds. So what we do here, we accelerate now the video. Obviously, we don't watch the whole video because it's a funny video, but I mean, it's more important to have a quick demo in this case. So we stop the video close to the end. You see, obviously, the buffering reducing now. And the reason is because the downloaded already finished, because Google, YouTube, sorry, but also the others are just pre-buffering. And you see from our logs that we downloaded 72 megabytes of traffic. So this video was a file of 72 megabytes. Now we change the policy. We apply a policy with video rate limiting. So we update the big IP. This is done statically, but it can be done using a PCRF or whatever. And then we play the video again on the iPad. So we start the video. The video is the same. As you saw, the video started immediately. So you see it's still a peak, and that's similar to the slide that I was showing with the test results. So you see a peak at 5 megabits in this case, so lower than the bigger one before. So this is consistent with the test that we saw. And then we apply the full pacing. The pacing in this case was at 1.5 megabit per second. And the reason was because we wanted to force the video down to 480p wherever it was possible. So you see 1.5 megabit per second pacing. We go back to the video. Now you will see the video at 480p, but it will go between 480p and 1080p, up and down, because again, the fact that you are pacing at 1.5 megabit per second, it's in some cases enough when the video, let's say, the video encoding permits, let's say, to have a chunk at enough bandwidth, so the video can move in terms of resolution. But in our case, we were still pacing at 1.5 megabit per second. You see the graph, you see the download that is finished. Now what we are going to do, obviously, we are going to see how much bandwidth we saved. So we want to analyze the amount of bandwidth that we consumed downloading this video. And you see that we moved from the 72 megabytes of the previous video that was available before. The new log now is showing 27 megabytes. And if you do your math, it's not very different from the 70% that we were showing in the slide before. So even reducing from Full HD to 480p, which is more or less what was done by the content provider during the COVID period, it's saving you between 65 and 70% of your bandwidth when we talk about full HD video. So I'm going to end screen share. And that, let's say, concludes my presentation. So the conclusion, just to recap what we said, is you can have unexpected events where you have to change the way you behave in your infrastructure, in your network. This unexpected event can change the way the applications behave, and you want to still deliver a good quality of experience on your infrastructure. The point is that service providers shouldn't wait for EU acting or content providers acting, even because, let's say we are lucky in some way because the number of content providers is not big today. We have a few big content providers that are delivering the majority of the video today. But if this number was big, it would have been nearly impossible to ask all of them to do the same on their network. So service providers can do something. There is the technology, F5 technology can help them. So you can use video technology, video traffic management technology to save your bandwidth for the use cases that we were mentioning. And you can even measure the effects, sending your log data to an external analytics tools that can give you an idea of the amount of video that is delivered and the amount of optimizations you can get, measuring what happened before the optimization and after optimization in terms of amount of traffic delivered. And that's the end of my presentation.
All right. Thank you, Raffaele, for a very insightful session. While you were speaking, I've been monitoring the Q&A section. So I would like to remind everyone, we'll start the Q&A now. Please feel free to add or to push any additional questions you have to the Q&A box. I will look at them after we've gone through the list of questions I already collected until now. So I tried to group them a little bit because there were a few questions related to that one slide that you showed where you showed the entire, let's say, F5 ecosystem on what we do in the video space. And there were a few questions not related to video optimization, but to some other aspects of that slide. One of them is, can F5/Nginx integrate with content providers to do caching more like a CDN?
Yes, we actually are in, let's say, we are discussing with the service provider to integrate our solution as a CDN. Nginx typically can play two roles. The first one is the cache engine that I was mentioning before, which is a very efficient cache engine that is already used by several content providers. It can also play a role of request routers, redirecting HTTP requests to the right cache. And the big IP, the F5 component, can play the request router as well, both from an HTTP perspective and a DNS perspective. So you can have a F5 big IP intercepting DNS requests redirecting the request to a specific NGINX, which can be either a cache or a request router in order to scale out the request routers and optimize even more to deliver the traffic to the specific cache engine. This is a very important use case for service providers, especially in the context of edge computing, for example. And the fact that the NGINX it's so small in terms of footprint and so efficient makes the solution suitable, very suitable in these use cases. So yes, we are definitely in contact with them.
Okay, and in the same context, there was a question from somebody asking, yeah, I saw the name of Akamai on the slide. Is Akamai using the F5 solution in their CDN for video streaming?
That information, I don't have the details on this, to be honest. And so I don't have details to share, and specifically on the Akamai part. What I can mention, as I said, content providers like Netflix. Netflix is publicly announced that they are using NGINX technology in their caching solution. As an example.
Okay. Yeah. Thank you, Rafael. Now going back into questions on video optimization, which was a key topic of this presentation. One question is, how do you detect when video is HTTPS based?
The way we detect video is based on different techniques. Obviously, we cannot disclose details because there are some kind of intellectual property on it. But it's typically based on traffic pattern analysis, heuristics solution. And there is an AI algorithm behind that is analyzing the sequence of the way the packets are delivered, okay, in order to make sure that this specific pattern can match with the specific pattern related to the adaptive bitrate streams. So obviously it's more complicated than that. You cannot do that based on the signatures because, as it was mentioned, it's HTTPS and it's encrypted, like Quick is, by the way. So it's something that is based on approaches, not based on signatures, as I said, but based on heuristic/AI approach.
Yeah, and a very related question, actually. How does a F5 video traffic management solution work in cases where the video stream is not encrypted?
It works exactly in the same way, I would say, in the sense that we are not in the business of transcoding. So F5 does not do any kind of video transcoding even because, let's be honest, it's not our main job. So our DNA, it's more on the traffic management part. So we detect the traffic as ABR, and in this case, it can be even easier because it's not encrypted. But the way we force the resolution down, we do the just-in-time emulation, it's exactly the same as the HTTPS part. So we apply bandwidth control functions to these streams, and we force, I would say, the client to behave in a very specific way.
Yeah. And it looks like there's quite a few questions around that topic on how it all works, right? So obviously in 40 minutes, we can only scratch the surface. So I would advise everybody that wants to learn more details, please reach out to your local F5 representatives and we'll be more than happy to give you much more details. So again, within the same context here is, how do you optimize Quick?
The way Quick works is the following. So we detect, the detection part follows exactly the same concept that we said. We actually do not optimize Quick as a protocol. What we do is we optimize the video that is streamed inside Quick. So we pace the UDP flow in order to make sure that the bandwidth that the flow is delivered is the bandwidth that is mapped to the resolution that we want to achieve as a minimum. As I said, sometimes you can get higher, okay? Because maybe there are some parts of video that there is not a lot of movement. So in the case of the demo, for example, 1.5 megabit per second was enough to deliver part of the video at 1080p. But obviously the final goal of the service provider is to save the bandwidth. So we're maintaining a minimum amount in terms of resolution. So if you can go higher, that's okay as well, as soon as you save the bandwidth that you are supposed to save. So let me put it this way: we do not optimize Quick. We optimize the application that is streamed inside Quick, managing the bandwidth of the flow where Quick is transported.
Okay. couple of questions now more related to the F5 product set. What type of module do you need for this function? Do you need standard load balancing LTM module, or do you need another specific module to do this?
Yeah, this specific function is done by a module called PEM, or Policy Enforcement Manager. So PEM has the capability to detect the ABR video. It has an application detection engine, and part of the application detection engine is also detecting the video. The application detection engine can detect around 4,000 different applications, and ABR video streams are part of it. And the bandwidth control part is also part of PEM. PEM is also, and this is the key point on the slide related to the dynamic policies I was mentioning at the end. It can be subscriber aware. It is subscriber aware. So you can provision the policies that are optimizing the video, but theoretically any policy that you want to implement a different kind of services, talking about something else, parental control or filtering of specific content, this can be done by PEM. So PEM is the module that is needed to implement this kind of service in service providers network.
And then given this is delivered by PEM, can this function coexist with other use cases mentioned in the slides, like GI firewall, carrier grade NAT, or any of the other functions that you mentioned?
Yeah, definitely, yes. I mean, this is part of, let's say, F5 value proposition. F5 value proposition on the GI LAN is the consolidation of different functions in a single technology, which can be a single element, or as I said, a single technology, because that helps anyway. So F5 typically offers this solution physical and virtual. And in the context of virtual, there is a solution called GI LAN, which is including, I would say, the majority of the functions that were listed in my slide, and they are typically charged based on bandwidth. So the customer can acquire the solution, they can implement the service, and they can be charged based on the bandwidth that is used in their infrastructure. It's a new way, obviously, of delivering products and solutions, which is more software driven. But yes, definitely yes. And as I said, it's part of our value proposition as a technology.
Okay, great. Here's a question. I'm not sure what CST stands for. What if CST puts the resolution manually? Not sure if you fully understand the question.
CST, I am assuming it's the customer. CST okay. Is the abbreviation of the customer. So if the customer puts the resolution manually, that depends. I mean, the algorithm tries to detect that the video is not ABR anymore, and it doesn't apply the policy. There is a success hit on this, and that can make, let's say, that gives you the possibility to avoid to stall the video. And this is the way you can implement the solution. Typically, when the customer changes the resolution, in the majority of the cases, but that can depend on the client, the client is opening a new flow, and in this new flow is requesting the video at that specific resolution. So that new flow, it's typically detected as non-ABR. It has to be detected as non-ABR, and then because it's non-ABR, we can avoid to apply the policy. That's in principle the way it works, but sometimes it depends on the client.
Okay. I'll answer this one. Is it possible to get hands on this demo if you're an F5 partner? If yes, how? Yeah, definitely. So if you're an F5 partner, if you're a customer, if you're a customer prospect interested in this, absolutely, we can share that. I would say reach out to your local F5 contacts. They will know where to find us, and we will give them everything you want to leverage. Let me see. Is there any other questions? Okay, here's an interesting one. Does F5 do video optimization based on location? And one specific aspect this is if traffic is coming from a more congested link.
Yes, definitely yes. We can do based on location in the sense that, as I mentioned, PEM is subscriber aware. When I say subscriber aware, means that PEM has the capability to store the subscriber information, which is not just the ID and the IP address, but it's also a series of attributes that can be dynamic, by the way, And one attribute that can be used, for example, is the tower ID, which is, it can be populated in different ways using radius packets, so snooping radius packets, or even received via, we did a test with the customer, which was just sending this information using a variant of a GX interface. I mean, F5 technology is pretty flexible and can acquire these attributes in different ways. So what you can be done is applying policies based on the content of the tower ID, which is the location that can be used. Any other parameters that can identify the location and you can think can be populated in a database can be used. So our technology is pretty flexible. In terms of congestion, we implemented a similar solution in different ways. There are two options. The first one that we did was having probes in the radio networks of the service provider measuring the congestion and sending feedback to F5 on the locations that were congested so that F5 could implement policies in order to optimize, so pace the traffic in order to optimize the video. This was one use case. Another one that we are working on a customer which is doing the same is using the explicit congestion notification bit. So the radio network can notify that a specific area is congested, sending an ECN, which is a standard bit in the IP packets. We can read this bit in the IP packets and apply the policies consistently. And last but not least, but this is still work in progress, we are working on metric analysis, analyzing the TCP metrics, trying to understand, this is still a work in progress. It doesn't really exist yet, the last part. But we want, let's say, to try to understand if we can analyze the TCP metrics and check that there is congestion because TCP is behaving in a specific way. These are the three options that...
Exactly, and this is indeed an area where we would definitely welcome some of your feedback from our customers in terms of what option is best for you, because collecting data from probes from the radio network is obviously very different from just looking into an ECN bit that is set by the radio networks, and there's pros and cons to all approaches. So yeah, definitely interested in hearing your views on that. I think we're reaching the end of the hour here. One last question, Raffaele. Does F5 recognize the end user device, and can we do optimization based on the subscriber device?
Yes, there are different options even here. Yeah, this could be a very long answer, but I will try to make it short. So we can do it. The simplest way is using the EMEI. I mean, F5 can be populated with the TAC database. And from radius, we can get the MEI of the device, and we can identify the device based on the MEI. This is one option. There is another option based on fingerprinting, where we can detect the operating systems and the type of device. So we do a mix analysis of user agents for the unencrypted flows, because there are still some unencrypted flows. We can do TCP fingerprinting as well, and we can do typically bandwidth analysis in order to understand if this is the only device that is generating traffic, or we have more devices behind, like a tethering-based solution. So there is a combination of these three elements, and we can do, obviously, in the second case, it's an estimation, I would say, because it's based on the traffic pattern. The first one is much more reliable, because EMEI and TAC database are deterministic information. The second one is more heuristic, but it's possible as well.
Okay, wonderful. So with that, we will conclude this F5 webinar. We'd like to thank you for joining us today, and I would also like to thank Raffaele for walking us through this interesting content. By the way, in the Q&A box, there were some compliments for the content, Raffaele, so very well done. Thank you
very much.
So look out for a link, everyone, we will share with you that points you to the recording if you want to listen to it again. We look forward to hosting you on future F5 webinars, and would like to remind you to visit the F5 My Forum web pages. because that's where you can customize and continue your own F5 learning experience. The My Forum is actually more a learning experience than an event. So please bookmark that page and go through that collection of live sessions and pre-recorded webinar sessions. Actually, our next My Forum session will happen tomorrow. And tomorrow's topic is in the Application Protect track, and it covers fraud prevention and the delivery of a friction-free customer experience, which is a topic that is very relevant for our service provider customers as well. So thanks again for being with us today. Stay safe and stay healthy.
Thank you.